Okay, let's now look at the speed of sound. Now remember, we've said this before, but the speed of a wave does not depend either on the pitch, remember that's our frequency, or does it depend on the amplitude? So just because you say something loud doesn't mean that it gets to wherever it's going faster. And the amplitude, I'm sorry, this should actually be also volume or loudness. Remember, those two are equivalent to one another. My pitch is given by the frequency and my volume is given by the amplitude. But no, the speed of a wave depends only on the medium. So remember we said this before, that v is equal to lambda f. But if I change lambda, that doesn't mean that my speed goes up. No, no, no. That just means that my frequency goes down. Okay, so a high-pitched noise or a high-pitched sound will not necessarily have a faster speed. No, the speed depends upon the on the elasticity of the medium. If you have a more elastic medium, then you have a higher speed of sound. This in general is true not just for sound waves, but any type of pressure waves or any type of wave in general, that if my medium has a higher elasticity, then that means that I will have a faster rate of moving, a faster rate for that wave to move through that material. Elasticity you can think of as being related to that restoring force. Remember the restoring force, like the mass on the spring? If I have a really stiff spring with a high K value, the high spring constant, then that means that the restoring force is really big. In solid materials, the restoring force is really big. And I drew this picture earlier, but let me just reiterate. Imagine I have this material, it's made up of atoms. I take this atom and I move it over here because a pressure wave has gone through the solid and it moves that atom out of its place where it wants to be. And then I have pressure pushing that atom back into its place. And in a solid, if that pressure is really big, just because of the nature of the structure of the solid, those atoms are all locked into place. And if you move one from its position, it's going to be forced back into that position really quickly and by a large force. So a higher elasticity means that you have a large restoring force. Not really the same way that we use that word in other terms, that, usually if we talk about something that's elastic, we think of it as being very stretchy. But it's really sort of the opposite here, that if I think of something that has a high elasticity, it means it doesn't stretch very easily, or it doesn't move from its equilibrium position very easily. Now, in air, sound travels at about, 340 meters per second. Seems like a lot. However, it travels faster in water and steel. In water, it travels at a speed of about almost 1,500 meters per second. And in steel, it travels like at 6,000 meters per second because that restoring force is just so large. Here are some questions you should be able to do on your quick test. And I'll pause there.